joining us. I'm sure a few folks will sort of filter in, in the next minute or so. But we'll spend some time. We'll go over a little bit of what we're going to cover today, and then kind of get into the meat of the presentation. So you are aware this is being recorded. The recording will be sent out at a later date, so look for that. If you do have any questions, please put them into the chat. There are folks from Menard on the chat that will be monitoring that, answering it as they go, and saving some of the good ones for the end of the presentation. So please, any questions you have, put it in there. For those of you who are looking for professional development hours, certificates will be mailed out to you at a later date. So look for that as well. So this is the fourth webinar in the Menard Canada webinar series. We will be talking about residential development projects. Kind of a quick overview of what we're going to cover. We will touch a little bit on who Menard is, what sort of challenges that we help you and help your clients solve, an overview of ground improvement techniques, but we won't spend a ton of time on kind of the ins and outs of all of the different techniques. And if you're interested in that, there was the first webinar, the introductory webinar, that has more details on that. You can reach out to our team if you're looking for the recording. We'll then get into some of the common challenges that are often associated with different types of residential development. And I think that's what is going to be interesting to a lot of people. And then do a bit of a review of some of the ground improvement benefits, and then of course have some time for questions. So please, if you do have questions, put them in the chat, and we have folks that are monitoring that. So who is Menard Canada? So we are a design build ground improvement contractor. If you don't really know what ground improvement is yet, don't worry, we'll get to that in a minute. We've been in Canada 52 plus years now. We formerly operated as Geopac, which was established in 1971 out of Quebec, and they were the first folks to bring the Menard pressure meter testing method to Canada, which allowed us to more accurately qualify what poor soil conditions, how bad are they, get some very good data, and be able to look at alternate solutions than your typical kind of dig and replace and bulk excavation and piling type approaches when you get on those sites. We brought a lot of really interesting technologies to the market in Canada. We mentioned the pressure meter. We were, of course, the first to bring in dynamic compaction in the 60s. Menard vacuum, which we won't really touch on today, but in the 80s, and then controlled modulus columns, which we'll end up spending a bit of time on today because it's a very versatile tool in the ground improvement toolkit that allows us to tackle a lot of different challenges. Menard is established coast to coast across Canada, offices in Vancouver, Kelowna, Calgary, Hamilton, 2 offices in Toronto, Ottawa, Montreal, and we continue to grow. So we've got a lot of good folks, good knowledgeable folks across the country that are able to help you. Please don't hesitate to reach out to them at any time if you have any questions after this webinar, someone that may be local to where you're doing your business. So Menard, we get involved in a lot of different projects, and it was when I was setting up the slides for this webinar, I thought it was kind of interesting that it's going to be a real residential focus for us. It's more about soil conditions than it is really application. So whether it's a 4-story, 8-story residential building, or it's a storage tank, or it's an embankment for a new bridge or railway. That just tells us how much stress is going down on the soil. And what we really focus on is what these soil conditions are and how we can manage them. But we will talk today about some of the specific soil conditions that are typical on residential projects, and how working with ground improvement helps us simplify that process of construction, particularly in a residential environment. So we work in a lot of different industries, but really anywhere you have challenging soil conditions, that's where we like to come in and see if there's something that we can do to help save you time, save you money, simplify your sites, and take the risk out of some of the unknowns in the underground. So when you're dealing with projects that might have loose fill, deep compressible soils, and if you don't, if you're not familiar with these types of graphs, all you need to know is that the red there is bad. these type of sites, there may be peats and organic soils. You got to find options to get these buildings out of the ground that don't cost you a fortune and take the the entire construction season to implement. Typically, what you're told or what options that are presented to you include things like bulk excavation. So you've got poor soils on the site, dig it out, replace it with engineered fill, bring in import of maybe granular material, sand and gravel. Maybe you're lucky enough to use common earth fill. Some of the challenges with this approach, of course, is that depending on where you are on your sites, a lot of these residential projects, particularly infill sites, for example, are being built property line to property line. So to remove poor soils, you're likely getting into shoring. You may be getting below the groundwater table. The soils may extend beyond that level, and you're getting into dewatering. And then this results in soil disposal, which is costly, trucking, and all of this has its associated embodied carbon as well. And we'll talk a little bit about some of the embodied carbon aspects of construction, because I know it's becoming more and more prevalent. Like the city of Toronto has recently announced that they're going to cap the embodied carbon on all new city-owned buildings. And it's something that Menard is working very closely together with our teams across the country to understand, what the embodied carbon of our systems is, how it compares to other systems, and be able to offer you some good metrics on what you can expect in terms of tons equivalent of CO2 per building area, for example. We have an interesting paper coming out later this year that some of you may be interested in, so stay tuned for that. The other option you're often given is deep foundations. Certainly with larger residential buildings, you might get into things like caissons or drilled shafts where you're pulling a lot of material out of the site, or it could be helical pile foundations, micro piles, things of these nature. These are often fairly costly to install. They also require more costly structural systems, so pile caps, grade beams, tie beams, structural floor slabs, which complicate and add to the expense of these projects. And then also, as we're focusing on that embodied carbon, a real kick to the project from that sort of standpoint. Obviously, everyone would like to be at high capacity, shallow foundations. So this is strip and spread footings. A number of reasons for that is that they use less excavation required. So you're generating less excess soil to manage, fewer materials, so less concrete, less rebar. These are often faster and more economical to construct in the field as well. Lots of folks are very familiar with this. As you get into pile caps and grade beams, you may need more sophisticated site trades to tie that rebar and do a good job of constructing those elements. And then shallow foundations, of course, have a lower impact on the project in terms of carbon and emissions and material uses. So this is a site here you see in the background of this slide. You can get a sense of some of the size of these pad footings. This is a project that was completed a couple of years ago by the Menard team here in Hamilton. You can see ground improvement being installed very close to existing buildings, right next to an existing slope. And ultimately, that's what this site looked like on Tuesday of this week. So it's a 7-story in the front, it's 8-story out the back, residential building. And if I cycle back, you can see the foundations that it was on. This site was originally planned for a relatively thick raft foundation throughout the entire development. So you can visually see the savings as opposed to bulking out a significant thickness for a raft, and compared to isolated footing excavation, saving a lot of time and money on these types of projects. So what is ground improvement, you might be asking? Ground improvement is sort of a catch-all name for a bunch of different technologies that really use mechanical means to improve poor soil conditions. Like we said, there's a bunch of different approaches that can be taken, sometimes in combination with each other to make a site workable for construction, help kind of get you from that sort of dirt to doorstep with these residential developments. Some of the more common techniques that we're seeing in Canada and that we're utilizing on projects include soil densification. So the number of different ways that we apply either impact energy or vibratory energy to the soil to densify it, tighten that site up, give it higher bearing capacity, control settlements, manage liquefaction risk. Our team out on the West Coast is certainly dealing with a lot of liquefaction related vibral compaction, for example, which is what you see on the far right here. With these techniques, you're generally not adding any materials to the site. You're simply using energy to densify the soils. That works up to a certain limits. Beyond those limits, you start adding materials into the process. You can use aggregate is a somewhat common approach. You can see here a number of different installation methods for installing a vibrostone column or an aggregate pier. Techniques that are suitable for treating 30 meters, 100 feet of poor soils, maybe 15 meters, and then smaller equipment for smaller projects. And obviously the goal here is to bring the right piece of equipment to a job site, no bigger than you need from a number of standpoints, obviously costs, but in terms of its environmental impact as well. And then there's certainly some limitations when you get into aggregate-based ground improvement, and a lot of those can be overcome with concrete-based ground improvement methods. So it's a controlled modulus columns. You see again a number of different sizes of equipment, setups of equipment, everything from very large rigs to go 30 meters plus on sites to more mobile rigs that maybe you get into the 20-meter range, 15-meter range, and it gets sort of smaller and smaller from there. Why would you even, I guess, start the conversation of considering ground improvement? Well, when you're dealing with challenging soils on your site, really what your main concern is settlement, right? It's total settlement of these buildings, roadways, services, differential settlement, within structures, causing cracking, all sorts of issues that are associated with that. And ground improvement is an engineered settlement control system. That's where it all starts. It all starts with settlement performance, and then the structural systems back out of that. We're able to increase the bearing capacity of a site. So you might have a site where your geotechnical engineer won't provide you any bearing capacity because you're in an undocumented fill or very poor soils. We can work that site, give you reasonably high bearing capacities to build off of, help manage some long-term deformation, because certainly you can put a structure up, but 10 years, 15 years, 20 years down the line, how is it performing? And then there's also in seismic events these risks that the soils may liquefy and cause settlement of structures, and there's ways that we work to mitigate that as well. I think from a construction standpoint, the main drive, I think one of the main reasons our clients like working with ground improvement is it simplifies the construction process. We're significantly reducing the amount of excess soil handling and disposal that needs to be done. So if you've got 2-3 meters of undocumented fill on site and you need to find a home for that, it's becoming more difficult to relocate those soils. Certainly here in Ontario with the latest excess soil regulations, that's complicating things. If you can leave it in place, densify, reinforce it, leave it in place, there's significant reductions. Going back to standard foundations and floor slabs, these also, we mentioned already, they move faster in the field, because they're easier to construct, they've got less materials. Some of the other benefits of that is, if you're building a residential townhome or single family home, for example, like the end user may decide one day that they don't like where you put the bathroom. Maybe they want it on the other side of the house, or they want to move some servicing around. And if you're in a structural floor slab system, that's very difficult to do. And ground improvement, allowing for standard floor slabs in those cases, gives a lot more flexibility for future modifications to these structures. And then, of course, there's time and cost associated with every kind of technique. But some of these big bulk excavation and earthworks operations, they take a lot of time, they cost a lot of money, and you can be a lot faster and more economical, often with ground improvement techniques. And then I think on sort of an overall, why ground improvement is when you get into challenging soil sites. I mean, there's a lot of risk in the ground. And if you can come in and you can de-risk that site by reinforcing the soils, taking away the uncertainty and the unknowns of, we're planning for standard footings, but we don't know if we're going to have to extend them deeper in some areas or what conditions we're going to find. When you reinforce the site, you reinforce it to, the lines and levels that are on the drawing, and that there's no requirement for over excavation of footings. And that that certainty allows your schedule to move along a lot faster as you go into construction. Like, we all know that some of these projects are taking years to get through permits and approvals, and when it gets time to actually get out to site, the faster you can be, the more seamless that process can be. That's a major advantage compared to some traditional methods, which leave some of the leave it to construction at the time of construction to manage some of these risks, like weak and soft soil zones, for example. So a bit of an overview. We'll dive into some residential developments and trying to find some, and then we'll, like you mentioned, some of the common challenges that our clients are often faced with, and that we help them out with. So when it comes to residential, and this is, this might not be the exact right headings for all of these type of projects, because you'll see we'll talk about subdivisions and low rise, and technically they're all low rise developments, but they are a little bit different in how they're executed. Subdivisions, whether this is single family homes, townhomes, they're often large sites in terms of area, and then they have relatively light structures that are placed on them. But when you have soil challenges on large sites like this, the costs and duration start to escalate, because you're dealing with such a large area. So, digging up a meter of coarse soils on an infill site, downtown somewhere, may not be a huge impact to the site, but digging a meter, off of a large development area is going to start generating a lot of soils, take a lot of time, and certainly be a lot costly. So I think when it comes to subdivisions, that's kind of one of the main differences from some of the other developments, is just the actual area that these projects are on. They also, often include a lot of things like roadways, a lot more utilities and servicing than what you're dealing with, maybe a couple low rise or mid rise developments on the project. So low rise, that's when you get into anything sort of 1 to 4 stories, so typically 5 stories or less. These are, again, in terms of some of the projects we deal with, relatively light, not as light as single family homes and townhomes, but you're starting to get higher concentrations of stress because you're 4 stories on reasonable footprints, and they just require high bearing capacities to support standard foundations and make that work economically. As you get into mid-rise developments, and all of these photos that we're showing you are projects that have been supported by Menard, you get into a lot more stress. Again, typically smaller areas, which means that you need that high bearing capacity to control the settlement and make your foundations work. We do see as the number of stories increases, we might be moving away from strip and spread footings, possibly into raft foundations, depending on the soil conditions. So there's really a distinct difference between that sort of mid-rise development and that low-rise development. And then high-rise. If you're developing a lot of high rise, anything over like 20-25 stories, you might be in the wrong webinar. Ground improvement, it's not piles. We're not doing the 55-story towers, downtown Vancouver, downtown Montreal, downtown Toronto. Really, we're focusing on this sort of low mid-rise development where we can offer a lot of value, and these techniques seem to work quite well. So what are some of the common challenges on residential development? So besides permits and approvals and labor shortages and material shortages and pandemics and all the other challenges that folks have to deal with, a lot of these sites that are being developed, maybe they're the leftover sites, maybe they're leftover sites for a reason. They may be low-lying sites. They may require, additional fill material, grade raise to be placed to get them up to their final elevations to manage some of your civil requirements, drainage, servicing. For example, that placement of new load on the site can be a challenge, and we'll talk about some examples of that in a minute. Brownfield sites. So there's been, former land uses. These, may have impacted soils. We'll talk about some techniques for dealing specifically with brownfield sites. Infill sites are another type of development. I mean, a lot of this is common, but what's changing is the environment that you're in. And we've got some interesting comments on, particularly on infill sites, and how to manage that without upsetting your neighbors, which is really the same as building addition projects as well, which we do a number of. Another common challenge with residential would be high groundwater conditions. So this photo is, maybe a bit more of a perched water condition than a high groundwater condition, but I can tell you that the groundwater levels were quite high on that project, and that's probably one of the reasons why they weren't getting a lot of drainage. This can complicate your site. It can complicate where you want to put your foundations. It can complicate what you need to do in terms of earthworks to actually make the site buildable. And there's some strategies ground improvement strategies that can help manage high groundwater conditions. And then the other one, of course, we mentioned previously, is seismic liquefaction. So earthquake events shaking the ground losing its strength and causing settlement of these structures. So one example of a project completed by our team out west. So this one's in Kelowna, BC. It's a large mixed-use residential development. Also had some sort of cool stuff going on with it in terms of boat stacking facilities and clubhouses for this boat club. But the site had 20 meters of loose sands that were at the risk of liquefying during earthquake events. It also had low capacity, and you can see here vibro compaction being used to densify that soils, mitigate that liquefaction risk, provide a higher bearing capacity, so shrinking down the footings, sticking with standard foundations, and helping to get that site up out of the ground without the expense of driven piles, pile caps, grade beams, structural slabs. We mentioned already with subdivisions, these are typically lighter structures. They often have, the intent is to have sort of minimal foundation requirements. These are, production units, trench and pour techniques, for example. Folks really like that, where they can get the foundations in as fast as possible. And they really prefer conventional floor slabs, as we talked about, in terms of, the ease for future modification, but of course also the cost of installation. These sites, having a lot of site servicing and roadways as well, often lend themselves to ground improvement techniques that can allow you to globally treat a site. So we mentioned techniques like aggregate-based techniques and concrete-based techniques. Those are most commonly installed, discreetly underneath foundation elements, underneath slab elements. But techniques like dynamic compaction, vibro compaction, another technique we'll mention here in a minute, allow you to treat the entire site. So you're not only dealing with the foundations and the floor slab, but you're dealing with the driveway and the backyard and the servicing that's coming into the building and the long-term performance of the roadways. And that can be very, very effective on these kind of larger sites that may have sort of larger earthworks operations. So this would be an example here of sort of this discrete support, like we talked about. So there's a number of projects we're completing all across Canada that are single-family homes, townhomes. We do a lot of this work with concrete-based systems because they're generally the fastest to install and the lowest cost compared to say aggregate piers. We're often in situations where maybe some of the vibrations associated with dynamic compaction might not be suitable when you're in residential neighborhoods. These techniques are very low to no vibration, so these are what keeping your neighbors happy, not damaging existing structures that may be next door. So pools, existing buildings. And then they allow, again, for that sort of that low complexity trench and pour foundation system. So a lot of work with controlled modulus columns, using a bunch of different setups, as you see here, from very small equipment to larger equipment to manage these types of projects. This particular site, so this is a subdivision in Keswick, Ontario, and for those of you who don't know the area, it's just sort of south of Lake Simcoe, but it's very soft soil conditions. The area is known for very poor soil conditions and having issues with long-term settlements. The developer was looking to build a number of single-family homes, and 17 units were being placed on this site, but they were challenged with about 20 meters of deep compressible clays. The concern there is that you put the foundations, you put these houses up, and then as the years go by, you start to get shifting and settling of the buildings, and they become unsuitable for occupancy. We took what a pretty interesting approach on this site using a combination of what we call wick drains and preloading. I'll show you an animation of this in a second, which will I think give a lot of context. But the idea here is that when you're placing new load on compressible clays, that settlement, the only way that settlement happens and how over time is that the water that's within that soil goes under pressure under new load. And as that pressure dissipates, the settlements occur. So if you can dissipate the pressure rapidly, say in 2-3 months, you can avoid the risk of long-term settlement. So this site used about 60,000 linear meters of vertical drains to relieve the pressure of the site, and then place anywhere from 2 to 3 meters of new fill over top of these units. So that the weight of that new fill was driving out that settlement, in a matter of a couple of months, and then was able to be removed, and the houses were put down afterwards, and are performing very well today. So this is a quick animation of the process. I hope it's not too choppy coming through virtually here, but what you can see is a high mass excavator rig stitching in these drainage elements. They're prefabricated. It's like a plastic core wrapped in a filter fabric. And then as you place the new load, that spacing of the drains allows for the rapid relief of the buildup of core pressure and causes that settlement to occur rapidly, as opposed to years or decades down the line. And that can be incredibly cost effective. This is a great site of a project just east of Toronto that was completed by our team. Very large residential projects, single family homes, townhomes, as you can kind of see, very similar to the development in the background. And wick drains and preloading were used on that site to prepare the entire development prior to servicing roadways and installing the units. So when it comes to brownfield sites, I think the most common challenge on brownfield sites is, what was there before and what did they do with the property? There could be fills that were placed in an uncontrolled manner, at least undocumented manner. There may be environmental contamination. There may be concerns, about buried artifacts on the site, whether it's tanks, old foundations, et cetera, that you may or may not be aware of. All of this typically means, you're doing a fair bit of earthworks and remediation work to get the site ready. You're likely generating a bunch of soil that's unsuitable for reuse as backfill, and maybe quite costly to remove from site. And all of that has a real impact on the project schedule and the cost and the duration. So if you can take those sites and de-risk the underground with, whether it's a dynamic compaction, as we're showing here in the photo, vibratory compaction, aggregate piers, control modules columns, fix the site before you develop, find and manage any of those issues without putting shovels in the ground, you can really get ahead on these sites. When you start digging, that you often start finding a lot of problems, and the more you have to dig, the more problems you're liable to find. So we like to minimize the amount of soil you need to manage, minimize the digging, like only dig as much as you have to, and get these sites built so they can get to market. We kind of combine infill sites and building additions because they have some of the very similar challenges. Often what we find on these sites is it's really about access and tight working conditions. They might have minimal material storage, for example, and using the right type of equipment makes a lot of sense. And then we show here a concrete-based controlled modules column ground improvement system where the material is being brought in every half hour, every hour in a concrete truck. So it comes, it offloads, and it leaves. We're not having to stockpile 1,000 cubic meters of gravel somewhere to keep up with production for, say, aggregate piers. You're definitely next to existing buildings, you're not going to do dynamic compaction. The vibration levels are going to be too high. So using systems like control modules columns that have no vibration, are relatively quiet, and have their require minimal material storage can be a real winner on these sites. And of course,
Being zero vibration, they have very little impact on adjacent structures, shoring, for example, as well as you can see, we'll talk about the building in the background here in a second. And then vibrations, we mentioned vibrations. So there's two types of vibrations, really, the way I see it. There's damaging vibrations, and then there's perceived vibrations. The human body is very receptive to vibrations. A lot of folks, neighbors in the communities, when they feel vibrations, they start thinking, the worst about their foundations and their property. And whether what you're doing on site is actually going to cause issues or not, that perceived issues results in a lot of complaints, and so it takes a lot of time away from maybe your site super who has to deal with these people and their concerns. Using no vibration systems like the rotary driven controlled modular column system helps to really alleviate that. We're also not dropping weights. We're not trying to ram and compact stone in the ground, causing a lot of noise. It's relatively quiet. There's not a lot of dust, and this particular technique, controlled modular columns, seems to be very well suited for these urban infill, tight access kind of projects, and we're doing a lot of work with them as a result. One of these sites is the 15-story mixed-use building here where I am in Hamilton. So this site had, it was maybe 5 to 8 meters of impacted fill, weak native soils, high groundwater conditions. There's an adjacent historic structure, a new building on the other side. A lot of challenges in that regard. Controlled modular columns on this site were used to support the development. They were installed right up against the heritage building without any issue. They greatly reduced the requirements for shoring. If you cut 5 to 8 meters of shoring off your site and the removal of all that spoil and the dewatering, that's a significant time and cost to the project that was able to be eliminated by reinforcing the soil from the underside of what was a raft foundation without ever getting in. We stayed about ½ meter above the groundwater at all times. So talking about some common construction challenges now. So those are the sort of the site related challenges. We're all familiar with the soil related challenges, but when you actually get up to construction, what we like to work with our clients on is things like sequencing of work. So especially if you're on a low-lying site that might have compressible soils and you need to raise grade, and that grade raise is going to cause settlement. When do you put in your utilities? When do you put in your roadways? When do you do the ground improvement work? When do you do the grade raise? Do you do the grade raise first and then reinforce it after? Do you do the ground improvement first and support the grade raise directly? And a lot of this conversation is really about working with the clients, understanding the schedule and sort of the objectives of the project, because every project's a little bit different. Some folks have some time to wait, and when you have some time to wait, you might have some more options available to you. Sometimes folks need to just build, and they need to get the ground improvement done, and they want a forming crew coming in, a few days later, and that changes how we might approach a project. So things like vertical wick drains, like we showed earlier, do require some time to consolidate that site, drive that settlement out. That may not be applicable if you don't have the time to wait, and you might get more into soil reinforcement with aggregate or most commonly with concrete to support grade raise directly, support utilities directly in foundations. Schedule certainty is a big challenge. So this is about delays. When you have unknown conditions on site and you start digging, and if your plan is bulk excavation, there's a lot of unknowns. That unknowns may result in obviously extra cost, because if you're moving more volume of soil off site than you anticipated, obviously there's a cost to that. But then there's also a duration to that, and it's not just the duration of the earthworks, but it's what that extended duration of your earthworks does to the rest of the project. So you delay a project by 2, 3, 4 weeks, maybe managing poor soil conditions, and that falls all the way down the line on your schedule when you're trying to line up trades closely together so you can get your projects out of the ground as fast as possible. This can cause major hangups. Of course, when you start digging and you get into groundwater conditions that are unmanaged, that's major delays to the schedule. And again, that goes all the way down the line, all the way to the person at the end of the day who might be, putting on the doorknobs and installing windows, who maybe have planned for your project for a certain time and now it's being pushed out, and maybe they do or do not have the capacity to manage it at that time, and it just really complicates the process. So dealing with that up front with ground improvement, reinforcing the site so that when you get down to the founding elevation, you're just putting your footings in, that can save a lot of headache on the duration of these projects. And then cost control. So everything costs money. Time costs money, materials cost money. When you're digging, and like we said, and you find extra volume of soil, I mean, there's a cost associated with everything. When we do ground improvement projects, we like to do them as a design build, lump sum project delivery. We agree on a price before we get to work. We go out, we take on the risk of the soil conditions and get that site ready for you in a way that allows you to control your costs, and you're not running into sort of the extras and delays that are often associated with earthworks and deep foundation systems. So we'll wrap this section up with just an overview of some of the proven benefits of ground improvement. So, really specific to a lot of different projects, but I think residential, has its sort of unique challenges here. Again, the first one and where it all starts from is settlement control. So engineered settlement control, you get the immediate and long-term performance of these structures, which is, allows you to build on some of these sites, which may otherwise have been unsuitable or very costly to construct. Maintaining those standard footings, maintaining that, standard floor slabs. Again, that moves faster in the field, help you get to that, hopefully that trench and core if you're that sort of low-rise residential contractor. Avoiding all the rebar, tying, pile caps, grade beams, like we mentioned before. Which is all about simplifying the construction, which allow you to rapidly execute the construction of these units once you finally get through the permits and approvals process, and it's time to actually get these things built. By leaving the soil in place, this avoids a lot of headaches. So whether it's excess soil management, whether it's like regulations in Ontario or extra costs per cubic meter to move dirt in Quebec, there's dealing with soil. The more you have to handle and deal with soil, the more cost, the more duration, and the less control that you have on projects. And if we can simplify that by just densifying or reinforcing that soil in place, there's major benefits to the project. And then, of course, that comes with the schedule certainty and the cost certainty that we discussed already. So with that, I'm going to open it up, see if there's any questions that came through. Please, in the Q&A, if you do have anything, pass along. Happy to answer your questions. If you think of something afterwards and you'd like to reach out to any of the folks from Menard across Canada, please do so as well. The first question I have here says, which types of soils / existing ground material do you normally see as having low bearing capacity? So that's a great question. There's a lot of different types of soils that may have low bearing capacity. One of the most common, I'd say, is fill. So there's undocumented fill soils that have been placed on a site in an uncontrolled manner. The old clean fill wanted signs. Your geotechnical engineer, rightfully so, isn't going to give you typically any bearing capacity on that because there's too much risk inherent in that soil, and that's where we come in to help manage that. Other types of soils would be soft clays and silts. So these are soils that have been often you might find these next to rivers and waterways, or as a result of outflow of old glacier lakes, for example. But they don't have a lot of capacity. They've been loosely placed naturally, and they tend to move a lot during when you place new load on them. And then the other would be just loose sands. Again, with loosely placed sand, When you talk about shifting and settling and differential settlement, that would be one. Of course, sands are relatively easy to deal with from a ground improvements standpoint. They respond very well to, dynamic energy, vibratory energy. You can stuff them full of gravel. You can put concrete in them. The challenge is really where things on our side start to get interesting is when we get into these silts and clays and fills and coming up with effective strategies for that. Next question I have here is at what point in the project cycle should Menard be contacted? So we get involved at all phases of the project. Sometimes we have folks are out, they're on a site, they've ran into a problem, and they call because they say, listen, we don't want to have to dig all this poor soils we just found out about. We don't want to remove it. We don't want to redesign our foundations. We've got strip and spread footings. We're ready to go. We don't want to bring a structural engineer in and design helical piles. So we're as late as when you're on site finding issues. And we're as early as due diligence of purchase. So we work with a lot of our developer clients. They're looking to build or to purchase a property to build on. They're aware that there are poor soil conditions, and they will bring that information to us during their due diligence prior to purchase and say, hey, is this something that's workable? What I generally say is the earlier that you can get us involved in a project, the better, because we can drive the maximum amount of value in talking about these options early before you start heading down a path like a traditional path that maybe big bulk excavation programs or deep foundations. So thank you for that question. Someone's asking if it's possible to work in existing buildings. The short answer is probably sometimes. It's not common. You're most commonly using ground improvement for new construction. Could be building additions and infill sites. If you have enough headroom inside of a building, it can be done. But generally speaking, how deep you need to go into the soils and how much room you have above, like headroom above your equipment, need to kind of balance out. A lot of these techniques, you only have so much mast, so you can only go so deep in the ground. So if you have 6 meters of headroom, that might be great. But if you have 12 meters of coarse soil underneath it, you might be out of luck. Question here. I think you missed a discussion on the type of soil and application types of ground improvement. So I hope we covered that in the previous question. I mean, there's virtually, there's very limited soils, I'd say, that aren't that can't be managed with ground improvement. It just depends on what you're trying to put on top. So like we said, we're not going to be doing 55-story towers, even 30-story towers, and certainly if you're on very soft sites, you need to dial back your expectations of what can actually be built. But there's a lot of different suitability, and if you're looking for more information on that, there is the webinar number 1 on the overview of ground improvement systems. So, question here about what we call load transfer platforms. So, design and construction. So when you get into concrete-based ground improvement systems, it is common to separate the footing with what we call a load transfer platform, which may be anywhere from 6 to 12 inches of gravel. So you have your standard footing come down, 6 to 12 inches of gravel, and then concrete-based ground improvement below that, or sometimes they're referred to as rigid inclusions. So the design of the load transfer platform would be done by Menard, based on our systems and our spacings and diameters, etc. Depending on where you are in the country and certainly in the province of Ontario, in terms of seismic requirements, will dictate how thick or thin, or if you need a load transfer platform on concrete-based systems. So can you confine the gravel material and proper compaction densification in a peat deposit, such as in Keswick? So I think the question here is, if you're using aggregate based reinforcement, how does that work when you start getting into very soft soils and organics and peat deposits? And I think the reason why that question is probably being asked is because folks know that when you work with an aggregate pier, it has no capacity, right? A pile of gravel has no capacity on its own. It relies on the soil around it to confine it to generate its capacity. So you're limited the softer your site gets, the looser your site gets, the less capacity you're going to get. And then certainly if you're dealing with organic soils, peats, it's just not suitable for aggregate-based ground improvement systems because the long-term performance can't be relied upon. I guess the opposite to that would be when you get into controlled modulus columns with concrete-based ground improvement systems. Concrete does have capacity, it does have its own capacity, and that opens up the availability of ground improvement for some of these sites that might have thicker deposits of peat and organics, or very soft, saturated clays. So the question here says that the choice of the improvement methods will largely depend on the soil type or conditions. Is it Menard or the consulting company who would provide the client with the choice of improvement methods? So, I mean, it's a great question. I think every project, when you're dealing with challenging soils, every project starts with your consultant. Your geotechnical consultant is the one that's going to go out. They're going to take the soil samples. They're going to do the initial investigation program. On these challenging sites, we're often doing some supplemental work using advanced testing to try to optimize designs and costs. But they are the local experts. They're the folks that are going to be with you through the entire project. After the foundation backfill, managing all your roadways, and you need to be keeping your geotechnical consultant engaged. A lot of consultants are aware of ground improvement. Some may have less familiarity, but there's certainly really good consultants out there who are aware of some of the advantages and limitations of the various techniques. What I'd say is that being sort of experts in what we do, we may look at a site a little bit differently, than your consultant might, just based on our past experience. And often what we find is that consultants are doing a general recommendation for ground improvement and then opening it up to more of a design build approach, which has its advantages and drawbacks depending on the type of project, and making sure you're getting value. Like if you're going out to the market with design build ground improvement, you need to be a little bit cautious of what sort of information you're getting from some folks. But your geotech consultant should be able to help you get the conversation started. And then you reach out to Menard to get maybe more specific information on budgeting and sequencing schedules, maybe options to look at different combinations of approaches to treat different areas. Like you might treat the floor slab differently than you treat the foundations, for example. The second part of that question is for deep compressible clay, so say around 15 meters. And the clients don't want to wait a few months for wick drains because of timeline limitations. Yeah, so we talked about that. Which method would be right to use in this case? If you're in compressible clays and you don't have time to wait, you're going to want to go with controlled modulus columns. It's the fastest to install. That's the first thing. It's typically the most economical as well. And then you're getting that guaranteed performance using material that again has its own capacity. 15 meters is well within the reach. I mean, we're reinforcing 30 plus meters of compressible soils with these systems all the time. I would add to that in some cases on those sites it may be advantageous to do a combination of wick drains and controlled modulus columns. Particularly to help manage, that long-term deformation outside of buildings, maybe, and possibly to optimize the slab support as well. The next question here is about stamped drawings. So, does Menard provide stamped drawings for grade, bearing capacity? You can use for the foundation design. Absolutely. So it's a complete engineered system, design build. So at the start of the project, we would issue shop drawings and design reports, for what we're intending to do. We execute the work, do our quality control verification. So that could be, full scale load tests. If it's compaction work, it could be, supplemental geotech, like post compaction geotech investigations to confirm we got the density. All of that gets reported into our final report. which is typically signed off by two licensed engineers, certifying the work for the site and guaranteeing the bearing capacity. So we do take on that liability. Everything from the underside of foundation down becomes a responsibility. Which actually leads well into the next question, which is, do you share liability and warranty with the project geotechnical engineer? The short answer is no. We are responsible for the work that we perform, and so we're taking everything from the underside of footing down. Now, there are cases where there may be ground improvement being done from a lower level, and then engineered fill being brought up and foundations there. So then there may be some mixed liability where we're providing a certain capacity at this elevation. The geotechnical engineer is responsible for monitoring and certifying the engineered fill, but ultimately the whole design of the system that says this thickness of engineered fill over this ground improvement system is what's certified by Menard. So it says, a benefit of using ground improvement that is worth mentioning is the use in contaminated land, as disposal of soil is minimal compared to bulk excavation. So absolutely. However, care should be taken to the chemical interaction with cement if it is being used. So yeah, Anna, that's you're absolutely right. A major benefit of ground improvement is leaving contaminated soils in place if it's appropriate to do so. And yes, we do run into situations where the contaminants or the material within the soil could cause issues with concrete, and it's something we'd work with our concrete supplier, things like sulfate resistant concrete mixes as an example. What is the minimum height required for the machine? So it really depends on what you're trying to accomplish. I'd say that minimum, if we can get away with it, is probably on the order of maybe 6 meters, 6.5 meters of headroom. And then that would have to, only be treating maybe 5.5 meters of poor soil in that case. The other questions about, so frost depth. Does the frost depth of foundations on reinforced ground change? And no, it doesn't. So one way to think about ground improvement, even though some of the stuff, this rig that we're showing here on the site, it looks like it could be a deep foundation rig, right? But ground improvement is a lot more, it's a lot closer to earthworks than it is to deep foundations typically. So you still have the same requirement for frost depth. It's also most common that the ground improvement is being used for compressive loads, so vertical compressive loads, as opposed to any sort of uplift, which if you're going to place foundations above the frost line, your concern there is that the frost is going to lift the foundations. So you need to either be looking at using insulation to protect those footings, or strapping them down with some sort of uplift anchor, but that's not very common. Usually you just go down to the frost depth. The other one is that any issues with ground improvements entering into/through water tables. So yeah, there's a number of challenges with water. High groundwater conditions on their own are well managed with ground improvement. That being said, if you get yourself into some of these pressurized aquifers, with artesian pressure conditions, that can be a concern for ground improvement. Certainly if you're trying to put concrete into pressurized aquifer, you're likely to flush out all of the cement, and those would not be an approach that we would take in those conditions. That being said, often when we're finding those challenges, they're at some depth in the profile. And there may be a lot that we can do before we get down to that aquifer level to improve the site. Like an example would be, and I apologize maybe for some of the folks kind of east and west across the country, very a little more familiar with Ontario areas. When you get up to say Barrie and Orillia, you get a lot of sands, deep sand profiles, and then there is the aquifer that the town uses in part for drinking water, and they're very concerned of what you extend through there. And we work with clients on shallow, whether it's densification techniques or vibratory compaction, or even controlled modulus columns to reinforce the site, provide the bearing capacity and settlement control without needing to extend to the depths where you cause those concerns. But yeah, absolutely, every project is a little bit different, and you need to be careful about what you're doing relative to groundwater. If you're creating pathways for contaminants, for example, like aggregate piers would be a concern with that. If you're installing aggregate piers through contaminated soils into a drinking water, that might not be something you want to do. And this one is your system competitive in areas with 1.5 to 2 meters of fill? Yeah, absolutely. I mean, it depends a little bit on the site and everything you're doing, but with relatively small equipment or with compaction techniques, for example, and particularly like if that 1.5 to 2 meters of fill, if there's some contamination in there, or maybe impacts, let's call it, that are going to increase the cost of disposal, it's absolutely worth reaching out and seeing if there's something that we can do to save you time and money. So in cases where Menard has come in and suggested alternate foundation designs, so as opposed to piles, going with strip footings on CMCs, how efficiently have other consultants adjusted their designs to accommodate the change in foundation, structural, mechanical, and how accurate are the overall anticipated cost savings? So yeah, I mean, when it comes to putting elements in the ground, like the question about mechanical is great. Imagine you've got these reinforcement elements, maybe they're everywhere from 1.5 to 3 meters on center and a grid underneath a floor slab, and you need to run servicing. So one of the things that we do and work very closely is getting our layouts right to avoid and anticipate the installation of those services. So that's one, and every building has below grade services essentially, and we support hundreds of buildings a year, so it's something that can be well managed. In terms of the structural, I mean, it's relatively straightforward. Most structural engineers are happy to design a strip and spread footing as opposed to a pile cap and grade beams, because it's just it moves out of their office faster. So it moves out of their office faster, it moves out of the field faster. There's a lot of benefits there. And the question jumped off, so I think there might have been a third part to that. So I apologize. I hope that answered your question. So it says, does Menard provide any sort of materials or general guidance on which type of improvement methods would be suitable for which ground conditions that make it easier for the start of work? Say absolutely. A great resource is our website. So it's menardcanada.ca. There's a lot of really good information there. I would say though is that we're very responsive. If you have a challenging soil site and you're considering ground improvement, pick up the phone, send an email. This is all we do. Ground improvement is all we do. We're looking at these new projects every day. There's things that we're going to see, opportunities, concerns, and often in very short order, without any cost or obligation, we can turn around sort of feasibility to you of these are the type of ground improvements that may be applicable to this site. Here's some rough orders of magnitude of what we think that might cost and might take, and then allow you to assess your options. So we're coming up on 12 o'clock here, so I'm just going to take one last question, and then we'll wrap this up. Again, I really appreciate everyone's time today. If you do have more questions, or if your questions were unanswered, we're going to do our best to come back to folks with a list of answers on that. So it says, since the geotechnical report is provided to the design consultant by the client, does Menard rely on this report for the ground improvement, or do we engage our own geotechnical firm? And they're asking from a liability perspective. So yeah, that's Devala. That's a great question. Yes, is the short answer. We do rely, just like every other engineering profession relies on every other engineering profession. We do rely on the information that's collected by the geotechnical engineer. Oftentimes on our sites, we are collecting additional data. So maybe, and it's quite reasonable to start an investigation with traditional, SPT sampling, test pits, things like this, to get a good sense of what you're dealing with. And then often to optimize ground improvement design, you may see us getting into advanced testing methods like cone penetration testing, with companies like Cone Tech, for example. And that really allows us to again, optimize, and then, you know, from that liability perspective, I mean, if we're owning that information, certainly that's with us. But there's, you know, it's not any different than any other report, you know, or any other system. If you're doing piles, the piling contractor and designers relying on the geotechnical report. If you're doing earthworks, they're pricing it based on the geotechnical report. We're also using the geotechnical report to assess the suitability of our sites. So thank you for those questions. And yeah, really appreciate everyone's time. There will be a few more webinars coming up. So the one in September will be on sustainability and ground improvement. So we touched a little bit on, you know, embodied carbon, and there's some really interesting work our team is doing on trying to quantify and understand where we fit into the spectrum and all that. And then in October, November will be both in French and then also in English, a talk on industrial buildings and warehouses. So with that, thank you so much for your time. You know, the professional development hour certificates will be emailed out to you. If you have any questions, feel free to reach out, and wish you guys all the best with the rest of your day. Take care.